All right, so let's do an example. Let's say you toss 2 dice. And let's say you let S be the sum of the top faces. And G equals X is the event that the green die shows an X. Okay, so if G equals 2, then the green die showed a 2, right? We'll use, guess what, R equals X to imply that the red die showed X. All right. So then, what's the probability that the sum is 5? What's the probability that you get a sum of 5? If you want to draw out your sample space and think about it for a second. Or you could count on your fingers, right? How do you get a sum of 5? 1, 4, 2, 3, 3, 2, 4, 1. There are 4 ways to get a sum of 5 divided by 36 possible outcomes. Okay? What is the probability that you get a sum of 6? Okay. 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. That's 5 out of 36. What else could we say? I guess what? Probability that the sum is 7. Do you know this? It's 6 out of 36, or 1/6. 7 is the most likely sum. Okay, 7 is the most likely sum. Now, what if I come along and I tell you though that, hey, guess what? I've seen the outcome of this, or I'm partially clairvoyant, and I know something about the outcome of this experiment here of tossing dice. And I say that, guess what? The green die is a 2. Okay? So I'm saying given that the green die showed a 2, given that the green die shows a 2, what is the probability that the sum is 5? Well, now the only way to get a sum of 5 is if the red one shows a 3. Okay? So given that the green die shows a 2, you know what? I'm getting a little confused here. I think now would be a good time for me to draw out my sample space. And by the way, I'm putting green on the left, red on the right. Okay? Oops. Five. God, jeez. Okay, I think that's right. Anyway, if it's not, then you can correct it. So given that the green die is a 2, where is the event that the green die is a 2? Very good. That's right. It's right there. So given that one of those things is happening, now I can get rid of all these other possibilities. Given that the green die is a 2, what's the chance that the sum is a 5? There's only one way out of those 6 ways. All right? It's right there. So it's one way out of these 6. Okay? So remember, you're getting rid of everything. The green die is a 2. That's your new sample space. Okay? One should be 1/6 by looking at the picture. The final answer is 1/6. But I'm going to also do this by using the definition, right? It's the chance that the sum is 5 and the green is 2. Divide by the chance that the green is 2. Okay? What's the chance that the sum is 5 and the green is 2? There's only one way out of 36 ways to accomplish both at the same time. And what's the chance that the green is 2? 1/6. And what does that reduce to? 6/36 or 1/6? Aha. So sometimes you can solve these problems by using, well, you can always solve these problems by using the definition, or sometimes it may be good or even easier just to think about drawing a picture. Okay? Let's try another one. What about the chance that the sum is 6 given the green is 3? Chance that the sum is 6 given the green is 3. And by the way, as I do these, feel free to stop the video, work it out on your own, and then make sure I got it right. Okay, so it should be the probability that the sum is 6 and green is 3 divided by the chance that the green is 3. Right? So what's the chance that you get a 6 and a green 3? There's only one way to do that if you look up here. Right? One way out of 36. And the chance that the green is 3 is 1/6. That's 1/6. Okay. What about now? What if I ask a different question? What's the chance that the green is 3 given the sum is 6? See how these are different? They look similar, but they're very different. Here you're asking for the chance of this event given that you've got this information. Now you want the chance of this event given this information. Okay, it's okay. They will in general be different. And let's see. What is this? This is the chance that the green is 3 and the sum is 6 divided by the chance that the sum is 6. Okay. What's the chance that the green is 3 and the sum is 6? That's a 36th, right? What's the chance that the sum is 6? How many ways can you get a 6? 5 ways, right? Divide that by 36. This is a 5th. Okay. And that's okay. So the observation here is that these two things are not the same. They're not the same. That's okay. Think about it like this. In a more important context, given that I find that I choose a guy at random, right? There are guys and gals, So given that so if I'm choosing a person from the world, then and given that this person turns out to be a man, what's the chance that that guy has prostate cancer? I don't know. It's probably like 4%. But if I flip the two, given that I choose someone from the world who has prostate cancer, what's the chance that that person is a guy? What is it? That's right. It's 100%. There is a biological reason for that. Okay. So be careful of this. You can't just willy-nilly flip things across this symbol. This symbol is here for a reason. Stuff over here should be thought of as new information that has been provided to you. And now you seek the chance of this event given that this new information has been revealed, okay?